Hello everyone, a very good evening to all of you. Welcome to Jatadhara Educational Technology. I'm Tripti and let's start with our NAVODAYA coaching classes. I hope you all are ready. Ready for it? So let's get started, dear children. Before we start with our maths NAVODAYA coaching class, let me tell you, we are live on YouTube and all the sessions go live on YouTube. So kindly subscribe to the YouTube channel so that you can get regular updates. And also there is a live chat option under the video. You can make great use of that live chat to answer the questions. Or maybe if you have any queries or anything, any doubts, you can ask me in the chat box. Okay? So I am constantly going to keep an eye on the chat box for your responses. So make sure you make full use of that chat box. Okay. So let's see what's our topic for this class. I hope children, whatever we do in a class, you are practicing that. And if not, I would request all of you to kindly practice to whatever we are doing, like whatever topic goes on in a class. Kindly watch the replay of the session and make sure that you are practicing. Okay. All right. So here we go. I hope my screen is visible to you all. Perfect. All right. So the topic that we are going to pick up today is fractions. What are fractions? Like actually fractions, there are so many things in fractions that we are going to cover up. So let's see what all things we are going to do today. Number system. What is number system? Numbers that are used to count or used for counting are called natural numbers. And you know, natural numbers always start from 1. 1, 2, 3, 4, and so on. Those numbers are called as natural numbers. Now let's count these fruits. Here is a watermelon. That means means 1. Here is 1 watermelon. How many apples are there? 2 apples. How many bananas are there? There are 3 bananas, right? 1, 2, and 3. Numbers that are used for counting are called as natural numbers, and natural numbers starts from 1. There are some special symbols that are used to represent the numbers like 1, 2, 3, 12, 15, 100. These are called numerals like ONE1, GW, like the 1, 2, 3, 1, 2, 3. These are all called as the numerals. These numerals are written using the digits 3, 12, 15. All these are digits that are used. We use Hindu-Arabic numerical digits like 1, 2, 7, 9, 15, 18, 100, 10,000. All these are like, we use Hindu-Arabic numerical digits. Now, let's consider the following. Number 1 is represented by the digit 1. Number 2 is represented by the digit 2. 12 is represented by 1 and 2. 1 and 2 together makes 12. But do you know, dear children, if I'll change their order, like instead of writing 1 first and 2 later on, if I write it as like 2 first and then 1 later on, it will make as 12. Right? So these numbers, like digits are only 2, 1 and 2. But if you change their order, the number will be different. Okay. All right. So I hope it is clear to you now. All right. So let's go to the next one. We can represent any number with a numeral made of appropriate digits. For example, 2, 3, 4, we can write, like using these 3 digits, we can make different numbers. Like 2, 3, 4 with 200, like 2 first, 3, then 4 is 234. 243 you can make by changing the order. Then 3 first, 4 and 2 in different orders, 342, 324. Then 4 first and 3 and 2 in different orders, 32, 23. So using the different orders, we can make different numbers with the same digits. All these 6 numbers are different, Numerals are different, but digits used to write them are same. The digits we have used 2, 3, and 4 only. Now, the numbers that are used for counting are called as natural numbers. Numerals are used to represent or write the numbers, and natural number starts from 1 and so on. Count how many eggs are there in the basket. Yeah. So, right, there are 4 eggs in the basket. Okay, children who are watching the session live, I would request you to kindly, if you have any questions, ask me in the chat box, or if you want, if I'm asking you any question, kindly reply in the chat box, the live chat. 4 eggs. Here, how many eggs are there? 2 eggs in this basket, and this basket has no eggs. There is no egg in this basket. That means I can call it as 0. Nothing or no. Nothing represents, like the word nothing is represented by number 0. Or nothing is represented by a number 0. There are 0 eggs in this basket. That's all. That's what I can say. The natural numbers and 0 put together are called whole numbers. Whole numbers starts from 0 and goes on. Whole numbers start from 0. Can you see that? Natural numbers start from 1. Whole numbers start from 0. But we cannot represent all numbers using whole numbers. Now, 2 boys have to share the fruits equally. Apples are there. How many apples each boy will get? So for that, first we need to see how many apples are there. So I can see that there are 4 apples, right? There are 4 apples. Right? There are 4 apples. Now, each boy will get how many apples? Each boy gets 2 apples, right? 2 boys have to share the fruits equally, and here each boy will get, like, now tell me, 1 apple is there. How many apples each of them will get? Obviously, if there is 1 boy and 1 apple and 2 boys, what will they do? If there is only 1, they will share equally by cutting it into 2 parts, 2 equal parts. Okay, now we use special numbers to represent part of a whole object. Part of a whole object. Whole means, what is this whole? This whole is full, or we can call it as complete, right? Fractions. The numbers used to represent part of a whole or unit are called fractions. When you cut down an object or anything into 2 equal parts or any number of parts, then each part is called as fractions. Let's see this square. There are 4 such square, right? Now each part, like if I just talk about this red part, how to write this red part? There are 4 squares and I have colored 1 square out of 4 squares. So this is what we call as a fraction. 1/4 is a fraction here. Yeah, 1/4 or 1/4, that is a fraction. Okay, is that clear to you now? So here basically what we are doing is, the fraction is used to represent, like fraction is a part of a whole, you can say. We read it as 1/4, 1/4 anyway. Okay, now this is 1/4. Here 1/4 means 1 of the 4 equal parts. So fraction is a part of a whole, and if you can consider, you can call a thing like a part as a fraction only and only if, you know, that is cut into equal number of parts. The parts should be equally divided. Okay, so this equally divided is what you need to remember. Equally divided. 1/4 means 1 of the 4 equal parts. This is also called as vulgar fraction. Now we studied some more examples. Let's see some more fractions. All right. Over here, one part is colored. I can see that out of how many parts? 2 parts. So this is 1/2, which is also known as half. Yeah, 1/2 is also known as half. Yep, 1/2 is also called as half. Means one of the 2 equal parts. You have taken out one part out of 2 equal parts. Equal. The parts should be equal. Now, tell me what is the fraction of this? One part you have taken out of how many? 1, 2, 3, 4, 5, 6, 7, 8. Out of 8. So the fraction of that part is 1/8 or 1/8. Means one of the 8 equal parts. All right, dear children. Okay. Now, can you tell me the fraction of this? First, you have to see all the parts are equally divided or not. I can see that all the parts are equally divided, right? So here, if I see it's one part has been taken out, like has been colored out of 6 equal parts. So it is 1/6 or 1/6. 1/6 or 1/6 means one part out of the 6 equal parts. Write the red portion as a fraction. How many parts are colored? Here I can see 2 parts are colored out of 6 equal parts. So the answer is 2/6 or 2 of the 6 equal parts. 2 parts, we are talking about 2 parts out of total 6 parts. Yeah? I hope it is clear to you now. Tell me the red portion as a fraction. What is the fraction of this red portion? Let's count the total number of parts. 1, 2, 3, 4, 5, 6, 7, 8. Total parts are 8. I have taken out one part out of 8 equal parts, which will give me 1/8. Yeah, it's 1/8. All right. 1/8 means one of the 8 equal parts. Right? Can we represent this red portion as 1/2? Can we do that? Can we represent this red portion as 1/2? Yes or no? No, we cannot. You know why? This is not 1/2. Do you remember I told you that the parts should be equally divided? Do you think the distribution is equal here? I don't think so. So the parts are not equally divided. We have to divide this figure into equal parts with each part equal to red portion. Each part should be equal to the red portion. So now can we call it as a fraction? What will be the fraction? Yes, now we can call it as 1/3. 1/3. Okay? Because all the parts are equal. Can we represent this red as this red portion as 1/2? Can we do that? I don't think so. Why? Because here, this is not 1/2 because this part is smaller than this one. So this is not 1/2. We have to find the area of this red portion and the area of total triangle to write as a fraction, which will be discussed in your higher classes. Even if I cut it into 3 equal parts and say 1/3, that is also wrong because this part seems to be smaller than this one, or the way it is written that you have to find the area of this triangle, then this, then this, then you can say. But it doesn't seem to be right. Okay? So this can't be called as fraction. This is 1 by 4. The upper part, 1, is called as the numerator. It is the numerator. Okay, what do we call this upper part as? The upper part is called as the numerator, and the part, the number which is written here, like number 4, which is written under this line, that is called as the denominator. But what do we call this line? This line, what do we call this line? This is called as a fractional bar. Fractional bar. This line which is in between is called as a fractional bar. Numerator over here, denominator here, the line which is separating both of them is the fractional bar. Numerator represents the part, like how many parts or part you have taken out. And the denominator represents the whole object. Whole means the parts into which the object is divided, full, or you can call it as complete, or you can call it as like total parts. Yeah. So in denominator, you write the total number of parts or complete number of parts. And in the numerator, you write the part that you have taken out. Okay. Or maybe you have shaded or, cut down. 1 by 8, 3 by 8, 5 by 8. You can see 3 fractions over here. Now, when the denominator is same, can you see in all the fractions the denominator is 8, 8, 8? When the denominator is same, greater the number, greater is the value of fraction. So if I ask which fraction is the greatest of all, so here 1 by 8, 3 by 8, 5 by 8, the denominators are same. Because the denominators are same, we can't compare using them. But that made our work easy. What do you need to do is, you just need to see the numerator. 1, 3, 5, which is more? 5. So we can say that the 5, we can say that 5 by 8 is greater than, hold on. So I can say that 5 by 8 is greater than, now 3 by 8 and 1 by 8. 3 by 8, which is greater than 1 by 8. Okay? I have arranged it in descending order. Yeah? Means from big to small. Or I can say decreasing order. Yeah? From big to small. Now 1 by 4, 1 by 6, and 1 by 8. What is here that I can see? 1 by 4, 1 by 6, 1 by 8. All the numerators are same. So when the numerator is same, greater the denominator, smaller is the value of fraction. So here it's different. When the numerators are same, like 1 by 4, 1 by 6, 1 by 8. So what happens is, if like there are 3 fractions I can see, 1 by 4, 1 by 6, 1 by 8. Greater the numerator, the numerator of denominator, 1 by 8 is greater. I can the denominator 8 is greater. 6 less than that, then 4. The fraction with greater denominator is the smallest. The fraction with the greatest denominator is the smallest. Here it's not the greatest. So first 1 by 8 is less than 1 by 6, which is less than 1 by 4. So this is the smallest of these 3, and this is the greatest. Fraction with greatest denominator will be the smallest, and smallest denominator will be the greatest. Okay, so here it's like ulta kind of, wherein you have to figure out, where you have to see which is smallest. The smallest will be greatest and the greatest will be smallest. Only and only when the numerators are same. Yeah. Now fractions with the same denominator, you can see here. Oops, sorry. Now here, what do we call? What is the name of the fractions with same denominator? So the fractions with same denominator are called as like fractions. Like means same. I am just like my mother, or my sister is just like me, or you look just like your mother, or you look just like your father. So like means same, or it means similar. Yeah. So the fractions which have the same denominators are called as like fractions. Okay. Like fractions. The fractions which have the same denominators are called like fractions. Now the fractions which have different denominators. See, if like means same, unlike means not similar, or we can call it as different. So the fractions which have different denominators are called as unlike fractions. Unlike fractions. The fractions which have different denominators. Okay? I hope that is clear to you. Perfect. Let's go to the next one. Now, there are some fractions which have the same value. Now, how can we get those fractions, or how we'll figure out that this fraction has the same value? See, those fractions are called as equivalent fractions. The name itself says equal. Equivalent means equal. 2/8 and 1/4. Both these fractions represent equal value, right? Of equal units, hence both have the same value. Consider this fraction 2/8. Now, I can also write it as 1/4. Why? Because if I do 2 times 1, which is 2, 2 times 4, it is 8. Like multiplying 1/4 by 2/2 will give me 2/8. Or if I reduce this fraction, I can see 2 and 8 both in the times table of 2. I'll divide it by 2. So I got 1/4. These fractions are called as equivalent fractions. Fractions that have the same value. These fractions are called as equivalent fractions. All right? I hope that is clear. Children, if you have any doubts, please ask me in the chat box. And even if you are not watching this video live, whenever you get doubt, you can comment on the same video so that I can take up your doubts. See, 2, 2 cancel, 1/4 is what you have got. We say 2/8 is simplified to 1/4. Okay? Simplified or reduced, we can say whatever here. Both are correct. All right. Now let's find out the simplified fraction of 8/10. You need to simplify, put it to its lowest term. See, 8/10 can be written as 4/5 because 2 times 4 is 8, 2 times 5 is 10, 2 to cancel, 4/5 is what you have got. Or another way of doing this is like I can divide, right? 8 and 10 can be seen, both can be seen in the times table of 2. So I'll divide the numerator as well as the denominator by 2. I'll get it as 4/5. That's my answer. All right? That's how you have to do it. Find the simplified fraction of 12/6. So here you can do it by this way also, or by multiplying. You see 12 and 6 both in the times table of 2 and 4. And yeah, 12 and 16, 2 and 4. So what I'm going to do here is, you have to take the greatest one to reduce it to its lowest form. So divided by 4, 3 by 4 is what I have got. Or you can also do it like 3 times 4 and then 4 times 4. 4, 4 cancelled. Answer is 3 by 4. Easy, right? Let's do the next one. Here, equivalent fraction with the same value, 1 by 4 is written as 2 by 8. We can say that 2 by 8 is equivalent to 1 by 4. We can choose any number to multiply the numerator and denominator, but make sure that you are multiplying or dividing, like whatever you are doing with the same number. If you are multiplying the numerator and denominator by the same number. If you are dividing, you are going to divide the numerator and denominator with the same number. It's not like you are multiplying the numerator by 7 and denominator by 9. No, it should not be like you are multiplying the numerator by 2 and multiplying the denominator by 3. No. Multiply or divide, whatever you are doing, just do it with the same number. All right. I hope I made this clear to you. Perfect. Now, let's go to the next one. Let's write some equivalent fractions of 3 by 4. See, you can multiply it by any number. Multiply the numerator and denominator by any number. I got 6 by 8. Again, you can multiply by any number. Here I'm multiplying by 4. And I got 12 by 16. Multiply by 11, 10, 16, 100, 200, 300, or whatever number you want to multiply with. You can do that. See? Here you multiplied by 2 and got 6 by 8. You multiplied by 4, got 12 by 16. You multiplied by 11, you got 33 by 44, 20, 60 by 8. Okay, so to find the equivalent fraction, you can multiply it with any number. Right? Let's do it. Over here, in this one, you have to find the equivalent fraction of 5 by 6. This is 10 by 12 and 15 by 16. So here 5 by 6 can be written as 10 by 12 because 5 times 2 is 10 and 6 times 2 is 12. So 10 by 12. If why not this, 5 times 2 is 10, but then I have to do 6 times 2 also. If I'm multiplying the numerator by 2, I have to multiply the denominator also by 2, which is not giving me the right answer. Okay, 15 is there in the numerator, 5 times 3, 6 times also should be 3 then, which should be 18, but here it is giving 16. That's why it's not right. 5 times 10 is 50 and 6 times 10 is 60, which is giving me the right answer. So B and D are the right answers. Now I want you to write some equivalent fractions of 2 by 5. Come on. Find out some equivalent fractions of 2 by 5. Multiply it with any number. Here I multiplied by 2, 4 by 10. Here I have multiplied by 3. I got 6 by 15. You can multiply by any number. I'm multiplying by 11. I got 22 by 55. Multiply by 10. You will get 20 by 50. You know, the easy ones are 2, 3, 11, 10, 20, 30, 50, 100, 1000. So you can multiply by any number. Now, here the question says you have to write the equivalent fraction of 3 by 4 and the condition is denominator should be 12. Now, what to do in this case? 3 by 4. The denominator should be 12. How can you get the denominator as 12? I can get the denominator as 12 by doing 4 times 3. If I'm multiplying the denominator by 3, I have to multiply the numerator also by 3. So I got 9 by 12. I told you multiply the numerator and denominator by the same number. The condition here is to get 12 in the denominator. So to get 12 in the denominator, I did 4 times 3. Okay. So let's see here. To get 12 in the denominator, we need to multiply 4 by 3. So 3 by 4 and here 4 times 3. Right? Nine by 12 is what we have got. The condition is fulfilled. Is that clear to you? Children, I hope I made myself clear here. Similarly, another question we have is, yeah, here, remember we have to multiply both numerator and denominator by the same number. Now I want you to write the equivalent fraction of 5 by 8 and the denominator should be 16. The denominator should be 16. What will you do? The denominator should be 16. From 8, how can I get 16? Yeah, 8 times 2. If I'm multiplying the denominator by 2, I have to multiply the numerator also by 2. It's 10 by 60. Okay, let's see. Right? Remember, we have to multiply both the numerator and denominator by any number we want. Okay, now here the fractions are 1 by 4, 5 by 6, 7 by 8. What do we need to do now? In all the above fractions, the numerator, if you notice, the numerator is smaller than the denominator. You see, the numerator is smaller than the denominator. 1 is less than 4, 5 is less than 6, 7 is 8, less than 8. Such fractions are called as proper fractions, where the numerator is smaller than the denominator. Or I can say the denominator is greater than the numerator. Such fractions are called as what? Proper fractions. Okay, such fractions are called as proper fractions. But what about the fraction wherein the numerator is greater, like the denominator is greater than the numerator? Wait. Yeah. Here, where numerator is smaller than the denominator, these are proper fraction. But what about like this 5 by 4? Where the, one second. Yeah. What about a fraction where numerator is greater than the denominator? Here you can see that the numerator is greater than the denominator. 5 by 4, 9 by 7. Such fractions are called as improper fractions. Improper fractions, where the numerator is greater than the denominator. Okay? How? Let's see. 1 by 4, 2 by 4, 3 by 4, 4 by 4. This is 1 by 1, which is called as one whole. One whole. This is 5 by 4, 5 parts. 4 out of, like here in 1, there are 4 parts. One whole plus 1 by 4. So that is how I got 5 by 4. Now over here, 5 parts out of 4 equal parts. That's how I got 5 by 4, which is an improper fraction. Okay. Now, one more thing we are going to do is, all fractions can be classified into 2 types. Proper fraction, where numerator is greater than the denominator. Improper fraction, where numerator is the greater than denominator. In proper, if I talk about proper fractions, numerator is less than the denominator. If I talk about improper fraction, the numerator is greater than the denominator. And on the number line, how do we represent fractions? Fractions which are less than 1 are proper fractions, wherein the numerator is less than the denominator. They are the proper fractions. And after 1, they are the improper fractions, which are greater than 1. You saw that picture? 4 in one square and 1 in the other. That is more than 1. Improper fractions as mixed fractions. How do we do improper fraction as mixed fraction? Yeah, over here, 1 whole and 1 by 4, right? 5 parts out of 4 equal parts. 1 whole plus 1 by 4, which is 1 by 4. 1 over 4. Right? 1 over 4. These are called mixed fraction. This is 1 whole. This is a whole number, and this is the fractional part. Yeah. Now let's add the fractions, which is going to be the last topic for the day. Okay. So what happens when we add the fractions? Over here, 1 by 6 plus 1 by 6. Whenever you add the fractions, it's like you do not add the denominators. You just add the numerators. So 2 by 6. 1 plus 1 is 2, 6 as it is. So it's 2 by 6. This can be further simplified, which is like reducing or bringing to its lowest term, which we have already learned, and we are going to learn it in our future classes. So we can say to add the fraction, when denominators are same, we just need to add the numerators. We do not add the denominators. Okay. So whenever it's addition, you need to add the, whenever it's addition of like fractions, you just need to add the numerators. You do not add the denominators. If it's 7 by 5, like 1 by 8 plus 1 by 8. So what it is? Okay, wait. It's 1 by 8 plus 3 by 8. So what is it? 4 by 8. So make sure you add only the numerators, do not add the denominators. Okay. So yes, children, with this, we have come to the end of our today's coaching class for maths. That's all for our today's class, dear children. I hope you understood whatever we have done in this class, and you will continue to practice and practice and practice to fix this concept in your mind. So yes, children, as I said, we are done with our today's class. I'll see you in the next class with more concepts, with more practice, and with more fun. So thank you so much for joining today's class. I'll see you in the next class. By the time, take care and have fun. See you.